Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be talking about 4.4, which is solving quadratics using the square root function. Some of these that we're going to talk about in 4.5, and also some of these we've talked about in 4.2 and 4.3, whether it's factoring or factoring using special cases. We're going to be looking at both of these things today. This is, again, just another technique, and at the end of Unit 4, once we've learned all these different techniques, it's really up to you which one you prefer. Just a matter of choice of what you want to do or what you're most comfortable with. So let's go ahead and get started here with our section. And today is 4.4. Which is solving quadratic equations by factor or by square root. So that's what we're looking at today, solving quadratic equations by square root. So let's just jump in and see what this looks like here. So if I give you a quadratic, let's say x squared minus 49 equals 0. By now you should recognize that that's a difference of squares. And so one way you'd be able to solve this is simply by writing this using your difference of squares formula, x minus 7 times x plus 7 equals 0, which means your answers are 7 and negative 7. Okay, that's one technique. Specifically here, what we want to do is use the square root operation to solve. And so looking at this same problem, rather than setting the quadratic equal to 0, I want to isolate my x term on one side and the constant on the other. Just like any other operation, addition, subtraction, multiplication, division, so long as we do the same thing to the left side that we do to the right side of the equation, then it stays balanced. So what I can do is take the square root on both sides, because that is an operation, and the square root and the square will actually cancel out. And then the square root of 49 is, remember there's always 2, plus or minus 7, which is the same as we got above. Now, if you want to write it separately, x equals 7, x equals negative 7, that's fine. Otherwise, we're using that plus or minus symbol. So that's pretty much it for this section. Sometimes they'll look a little bit differently. Let's say x squared minus 1 equals 24. Well, like I just said, we want the x squared term by itself first before we start taking the square root. Well, that's easy. We just add 1 on both sides. And now we can take the square root. And that's optional if you want to write that as a separate step, putting the little square root sign there. But square root and square cancel out. And the square root of 25 is plus or minus 5. So these are pretty straightforward. One thing that may make a difference here is if you have a case where, let's say, you don't have a perfect square. Right, we're using difference of squares in all the examples that we did in 4.3, where you're getting an integer, right? 49, 64, 81, 100, so on and so forth. But if you didn't have that, let's say you had x squared minus 40 equals 0. Well, 40 is not a perfect square. You could still technically do a difference of squares, but usually if we don't have a perfect square, we're going to add 40 on both sides, then take your square root. So x equals plus or minus the square root of 40. And like we did in Unit 0, then you need to simplify the radical if you can, whether that's using your factor tree, whether that you can see which perfect squares are going into that. This ends up breaking down into square root of 4 times square root of 10. And square root of 4 is 2, so my simplified answer would be plus or minus 2 radical 10. Again, if you need a review on how to get from here to here, that would be back in Unit 0. Okay. Let's do one more. Let's say x squared minus 70 equals 2. Same thing. add 2 on both sides, take the square root, square root and square cancel out. 72, and that can be broken down into square root of 36 times square root of 2. And if you need to write that step, you can. And the square root of 36 is 6. So simplified answer is x equals plus or minus 6 radical 2. So all of these are basically kind of written in standard form, right? We're writing it out. Rather than getting everything equal to 0, we're taking the time to get the x term by itself and then to get the x term by itself and then to take the square root. Sometimes it's going to look a little more like vertex form. In that case, the process is the same, which we'll show you right here. So let's say instead of just having a plain x squared, let's say I had something like x plus 5 quantity squared minus 3 equals 13, for instance. Well, now I have a parenthesis set. If I wanted to, I could expand that out, but then I'm not going to be able to use properties of square root. So instead, what I'm going to do, I'm going to treat this parenthesis set as though it was my x term. So I want that by itself. So I'm going to add 3 on both sides. Now that I have this parenthesis set by itself, I'm going to take the square root. So just like before, if you want to write this middle step, you can. The square root and square cancel out, which leaves you with x plus 5. And then the square root of 16 is plus or minus 4. There's no exponent anymore, so I can drop the parentheses. Okay. I'm going to get x by itself. So I have x equals negative 5 now, plus or minus 4. Which means my two answers are going to be x equals negative 5 plus 4 and negative 5 minus 4. And those would be my two answers. So anytime you have a problem that's dealing with that parenthesis set, you want to get it by itself as though it was an x term. Let's try another one. 2 times x plus 3 quantity squared plus 4 equals, let's do 68. So same thing, treating that as though it was my variable. I would first subtract 4 on both sides. I would divide both sides by 2. And now I'm going to take the square root. For your assignment, all the answers, unless I made a mistake, but more or less all the answers are going to be integers. Here it's possible that you get one that you have to simplify the radical like we did here in example 3. That's totally okay. Same steps. So go ahead and take the square root on both sides. That's going to cancel out. Square root of 32, I want to simplify that. It becomes plus or minus 4 radical 2. And then I'm going to subtract. Now, when you have a term that has a radical and a term that doesn't have a radical, there's no real way to combine those. You could do a decimal approximation if the book or your instructor asks for that. Otherwise, we're just going to leave it as negative 3 plus 4 radical 2 and negative 3 minus 4 radical 2. And that would be my final answer. We'll leave it as a complex number. That's pretty much it for this lesson. Hopefully it's pretty straightforward. If you have any questions, please reach out to me. Otherwise, I will talk to you soon. Have a good day, guys. Bye.